All right, welcome back, instructors. EL 140 Residential. This is Mr. Sanchez, West Covina campus. Obviously, we start our day with putting all our contact info, all our requirements for our set to make sure that we have everything listed on the board. That's what you always start with. You can start with, like I do most of the days, having some type of plan, whether it's a drawing, floor plan, electrical schematic, one-line diagram or ladder diagrams, to show the student how to illustrate their and document their project. Okay, we're going to be moving into phasing and dressing down a panel today. So come and follow me over here. This lab, it states objective is properly make up and phase a residential panel. That's pretty general. That's pretty general as an instruction. You go into the procedural things, and it's pretty basic. All they're asking you to do is show the student maybe how to knock out knockouts from the panel of various sizes, how to use the proper connectors for those various knockouts, whether it's a 3/4, a 1 inch, a 1/2 inch, and then bring in some type of conductor run, whether it's a simulated here of a non-metallic cable of different sizes and dimensions, or you want to have them bring them in an EMT with fished wires of different sizes and gauges. The other thing you're going to want to simulate is, like here in California for one, is we have Title 24. We have a big push for electrical appliances, heat pumps, air conditioning, heat pump, water heaters, car chargers. They're all being required, solar. So everything that's going to be pretty much in the future, double pole, 2-pole breakers. So it's going to be important that you illustrate to them how to get those heavy loads and phase and balance the amperage usage for those various loads that are going to be quite common in the future and even today already. So this part of dressing down, that's just workmanship. You know, lining out. I usually tell my students, I use my grounding back wall here as my grounding pathway. So I'll take all my groundings from every entering circuit and take it to the back wall, and then take it back over here to the far left where we have the grounding bus. I'll have create a pathway for all grounded neutral conductors to the center of the panel, and then to take their appropriate pathways to the left or to the right, coming up in the channel that's provided in this area. Some of the panel configurations are different depending on where you're at, but they're very similar. Then I'll utilize my HOTS, being that the ungrounded HOTS, the ungrounded conductors, are the last conductor to be applied. I'll have those to the front of the cabinet, the front panel wall. Come back, take whatever side is necessary, take it back to the back wall and up, and hit those pertaining circuits for those ungrounded HOTS. As we know, the combination breaker that's going to be required nowadays is going to have us taking a lot of our neutrals from a neutral bus straight into as well the breaker itself. So that's something that needs to be explained explicitly as well. One of the things that I point out is balance and phasing. What does that mean to them? They need explanation. They need detail. How do we simulate these loads that they're going to be dealing with in a home? Simple. We Google appliances that we would find in a home, and we can get nameplate data from manufacturers from those appliances, and we can simulate those calculations based on real numbers, real appliances that they could find in a home. And we can apply that to that curriculum in here of calculating and phasing out the A and B phase to make sure that we're pooling equally. Another thing that I'll do is I'll introduce to my students here in California the Title 24, the California Electrical Code, because there's some additional requirements that we have here to consider when it comes to this subject. One of the other things I'll unlikely explain, to them that they're not going to be really responsible for dressing down the panel when they first enter the field. their responsibility is to bring those home runs in, make sure that they're labeled, make sure that they determine with the person whose responsibility it will be to dress down the panel and to balance and phase and create a plan. It's gonna be that they're gonna want a certain amount of excess. So explain those practical concepts of leaving a full length of the panel length of excess conductor, sometimes double, so that that person has the option to move circuits around according to their plan that they determine. One of the other things that I think is a good start is have them draw it on paper. Have them start with a paper plan outlining where they would balance and phase and where they would place their circuits so that they're not compounding a certain area with heavy loads. There's a lot of things that we could add in to really make this, the curriculum of this lab experiment a little bit more in depth, and it's all centrally related about this subject. So good luck. Remember, follow the plan, follow the curriculum of the material. Don't forget to make sure that you tell your students, do not do any type of work with the feeders of the panel that is being provided with power. Everything that they're touching is downward of those incoming feeders. Lastly, I would say, one of the things that you want to point out to them is that they should know all the different components. They should know what bus is for what bus, how they're interconnected or not, or how they're isolated. We're gonna go through all those descriptors and we're gonna break down. Some people might color phase and use black and red, but that's not typical in every installation. It's not necessary. What's more important is having the circuits phased and balanced, but also labeling is very important concept to explain to them. So going forward, just kind of give it a plan yourself. Come up with a plan how you feel all the little details that maybe is not mentioned in this lab exercise, but you can fill in with the fact that, one, what kind of separation you want, what path do you want them to take, where do you want your grounding, is it too excessively coming out the other side. Explain to them about torquing conditions, torquing requirements, whether it's the lugs, whether it's the buses, whether it's the breakers. Explain to them all those concepts that a usual inspector would come in and look for himself. Overall, it's going to be for you to elaborate when it comes to what's going on in the central heart of our electrical system. I can fill this whole lab with utilizing all the time, even though the instruction here is very simple. So you got to bring your expertise, your experience, your research, your knowledge of the codes into this lab, into this exercise. All right, good luck. I'll see you in lab.